Good morning. This is Mr. Waters and another video from Waters Studios. We're continuing our study of logarithms. You should know that actually we've come pretty far, and we're going to have we're almost done. We've got a couple of more topics in logarithms and exponents that we need to study, and then we are going to have our test. That will be, I would guess, next week is when our test will be. More about that later. But for today, we're going to talk about a couple different topics. First is this natural constant called Euler's number, E. And it's a natural constant like pi, occurs in many, many different situations. You've got it on your calculator. Let me show you. It is, I'm going to zoom in for a second here. On my calculator, it's right here. As you can see, it's right next to the log key. You've got this other key that says ln, and then above that it says e and then a blank, okay? And that's that special e number. On my calculator, it's also, as you can see, down here, right next to pi. Anyway, what is that number? That's what we're going. What does it have to do with logarithms? That's what we're going to figure out this morning. Okay. Zoom back out again here. There we go. We'll come back to that calculator in a minute. Let me go ahead and do that again. Very good. Okay. So, without going very far into the history of it and where Euler's number comes from, E is a natural constant that works out to be about 2.7. Okay, like pi, it's a irrational number that has an infinite string of decimals that don't repeat and have no pattern that anyone's ever discerned. E comes into many different situations. Euler's constant does, and everywhere from finance to natural sciences. Anyway, so on your calculators, you will see, if you look for it, and I showed you on my calculator where it was, a key that says ln. That is actually a log key, and it stands for natural log, and specifically it is log base e. Now, as I said, I'm not going to try to tell you on this video where e comes from. Okay, maybe we'll have time for that later on, or I can send you to some web resources to do some more research if you're interested. But what you need to know is when you see ln on your calculator or in a problem, it means e. Okay, so we can make a table of e if you want. Okay, -2. Let's see, this is going to be x, and this is going to be e to the x, just like the table of exponents that we made before for other powers of e. And we'll start at 0, 1, 2, 3, right? And with my calculator, this is e to the 0 power, which is 1, e to the 1, which of course is e, which, as I said earlier, is about 2.7. E squared, e cubed, right? And if you graph it, e squared is approximately 7.3, is approximately 7.4 rounded off, okay? And e cubed is approximately 20.1 rounded off, and the e graph, I didn't show you any negative values. -1 would be 1 over e and so on, right? So that would be about 1 over 2.7. And if you graph e, and try it on your graphing calculators, you get this swooping exponential graph just like all of our other ones, okay? And now, of course, ln, which remember means is shorthand for log base e, okay? That's this flipped around, right? So it's, you know, 1 over 2.7, which is -1, and then 1, and then 2.7, and then 7.4, and then 20.1, and these go with 0, 1, 2, 3, and so on. Just like we flipped 2 to the x power into log base 2 and 10 to the x into log base 10. Okay? Anyway, so that's a little introduction to our natural log e. When we evaluate natural log e, it's on your calculators here. Okay? And it's usually right next, hopefully that's not too tiny for you. It's usually right next to the log base 10 key. Okay? So if you're looking for it, that's where it is. Now, what do we do with that? Well, what we do with that is, in this first is we can evaluate our calculator. So for example, what would ln2 be? So on our calculator, now remember that means log base e of 2, which is equal to some number. Now because that's an that's equal to some number x, right? Or right, we don't know what it is. Changed into an exponent, that would be e to the x is equal to 2, right? So now, because it's on our calculator, we can go ahead and we can evaluate it. All right. So our first little video here, quick video, is going to be just you using your calculator to evaluate ln values. Okay. So I'm going to go onto my calculator here, and so I want to know what's ln2. I find the ln, boom. I push 2, boom. It's about 0.69. So that's equal to, that x is equal to about 0.69, right? Round it off, let's call it 6.93. I guess we'll round these off to 3 decimal places, right? So that means that approximately e to the 0.693 would be equal to 2, which if you look over here, kind of makes sense, because 2, as you can see, is between 1 and 2.7, and 0.69 is between, that is the y value of 2. Over here, the e to the x value is between 1 and 2.7, and the exponential value, the x, 0.693, is here. I know I'm using x here, but really this is the y number from the exponential function. I hope that's clear. Okay, so anyway, so how about another one here, ln20, right? ln20 is 2.996, and so on, right? Since it's really log base e, it follows this, all the rules and patterns that other exponents have worked out, or that other exponent and other logs follow. The 3 laws, the laws of exponents would apply to the e, the e exponent. The laws of logarithms would apply to the laws of, you know, to the ln, the log base e. Okay. All right. Now, what I want you to do is just play around on your calculators with this log base e. All right, and then I'll come back, and in the next video we're going to use this to solve some word problems. And then when we're doing that, we'll be using that to solve some word problems. Okay. Alrighty. So do these, please. And also, these will be on your classwork that I'm going to post that you should practice with. So on your calculator, do ln 4, do ln 7, do ln 8, do ln 100, do ln 2.69, because sometimes the input number is not going to be nice even value. And then, ooh, just for kicks, let's try ln -2 and see what happens then. Okay, so put your video on pause, do those, and then come back, and once you've tried them out, come back and check your answers. Okay, I'm back. Hopefully I'll zoom in, I think, a little bit there, so you can kind of see both. Okay, so there is ln 4, and we're going to round off to 3 decimals, 1.386. Okay, put that in red. ln 7, 1.946. The squiggly equal sign, by the way, means approximately equal to 1.946. ln 8 is 2.079. See how it gets gradually larger, right? Because the log function graph is going to look like the ln function graph is going to look like this, just like our other log graphs. There it is, that we did earlier. Okay, so let's back again here. So let's see, ln 100 is 4.605. Slowly it gets larger, but it doesn't grow very rapidly. Okay, so ln, if we do ln 2.69, that is 0.9. Okay, and that rounds off, as you can see. So that's going to round off to pretty close to 1, isn't it? Right? So so we're going to call that, since we're rounding off to 3 decimal places, that's actually a little less than 1. So we're going to round that off to approximately, well, you know what? I don't like calling that 1 because that's not equal to 1. I'm going to take that out to 4 decimal places, so I don't have to round it off. It's an unfortunate choice. I'm not going to, okay, because if that were 1, that would have to be exactly something else. Okay, so that's about 1. Okay, and if we rounded it off to 3 decimal places, just to be clear, that's where it would be. And then ln -2. Okay, ln -2. Boom. Whoops. It says error cancel. Right? What does that mean? Oh, well, because remember, if we look over here, here's 1. ln 1 is 0. Here's ln 2, here's ln 3, here's ln 4, here's ln 5, and so on, right? Which are all these values here. But ln -2 is over here. There's no log function over here. It's undefined there. So this is undefined, right? In fact, if you tried even ln 0, also undefined, because as you see, this x equals 0 line was an asymptote, and the log function never crosses over, so even ln 0 is undefined. right? If we try some really tiny number like ln 0.00001, you know, ln 0.0001, four zeros, ln 00001, right? We get something negative. In other words, so that's negative 0.513, negative 11.513. As you can see, at a tiny value of 0.0001 right there, that's down here in the negative range, right? The x value is, or rather the y value is. And the closer we get to 0, the further down this will be. Try it out. The bigger negative that will be. So in fact, any value for a logarithm between 0 and 1, which is a fraction, will give you a negative number here. Okay? Very good. Okay, so that's enough for now. And I'm going to put, this is about the log function, or rather the ln function, and Euler's constant E. The next video is going to be about solving some word problems using, by solving exponential equations, including the natural log ln. All right, very good. Toodaloo.